Welcome back. So this was the last slide where we discussed about natural disaster in India. Now, as I was talking about that there are many agencies at national as well as at state level who have taken proactive actions or maybe the initiatives to minimize the hazard in different ways. So this is what NDMAs talk about, is that the disaster management is one of the most important activity which can reduce in total the life loss as well as the property loss during any kind of disaster. So what is important is that what we were talking yesterday also and the previous lecture, that this is on preparedness. Okay, so there is a mitigation part, and so any disaster occurs, then there has to be an immediate relief, and this will depend on the preparedness. So before an event comes, what is your preparedness and what is your understanding about that event is extremely important. So immediate response has to be there, otherwise if you delay, you are going to see more number of fatality, or the number of people getting killed will increase if the relief has not been given immediately. And then so assessment is important, because that will help us in the way that how we are going to deal for the reconstruction and the rehabilitation. The people who got affected, injured, lost their houses and all that, how we are going to rehabilitate them, actually that is very important. Of course, to some extent we can prevent, but I would say that you can just minimize the hazard or the risk part if you are having good capacity building, and this capacity building is in process what we talk about the mitigation and the preparedness. So disaster risk in India are further compounded by increasing vulnerability related. One is changing demographic and socio-economic conditions. So we see that few states are overpopulated, people have moved or migrated from one area to another area depending on the socio-economic conditions. And of course, if you are having in the rural areas, the construction pattern may not be up to the mark to withstand any disaster, any kind of disaster, then the life loss as well as the property loss will be much higher. So this is another part is unplanned urbanization. Now without having the preparedness or the understanding of the hazard, we are going very fast in terms of development. So unplanned urbanization, development within high risk zones. So when we understand the hazard and which areas are prone to the particular hazard, then according to that there will be the zonation. As for example, in the previous slide we were talking about the microzonation or macrozonation of India, which has been given based on the earthquake history, that the whole India can be subdivided into 4 categories, from zone 2 to zone 5. So depending on the different hazard, you have the risk zones which could be allocated, and based on that you can minimize the hazard. But to some extent what we experience that is heavy loss in terms of the building collapse or maybe the property getting affected as well as people is because of unplanned urbanization development within high-risk zones. Environmental degradation, climate change, geological hazard and epidemics will also add into the more disasters. All this contribute to a situation where disasters seriously threaten India's economy, its population and sustainable development. Because any country, the development of any country will depend upon the sustainable growth in terms of economy, in terms of the infrastructure also. Now, if that is going to be disturbed, we are definitely going to be affected towards our growth. These are few examples of major disasters which occurred during 1972 up to 2014. This is we are talking about 2014. 2015 it was in Nepal, but of course you can add more here as we were giving in examples in the beginning itself, that we had like 2018 flood in Kerala. So similarly you have many hazards, but if you look at the different type of different hazards here, including flood, cyclones, you have list of that, and it has affected many areas. Coming to earthquake, tsunamis, earthquake in Kashmir 2005, floods in Maharashtra, cyclone Nisa, Kosi flood in 2008. So this was also again a very deadly event in terms of the flooding event in Bihar because of the Kosi flood. Okay. So you can look at, and then another one is that since last couple of years we have been hearing about the cloud burst, that is sudden pouring down of the water from sky, is cloud burst, and which resulted into the landslide in Ladakh. That was in 2010. Then earthquakes, floods, earthquakes and all that. So you have several such events which goes back up to 1972, which talks about the different kind of hazard, which includes floods, earthquakes, landslides, tsunamis and so on. Now coming to earthquake, let us see quickly what we learn about this, but of course we will be talking in detail later on. In general, the Asia Pacific region alone records 70% of world's earthquake measuring magnitude 7 or more on Richter scale. At an average, if we take 15 events are occurring per year, that is of magnitude 7 in this particular area, that is the Asia Pacific region. The countries of the region which are badly affected by earthquakes includes Japan, Philippines, India, Nepal, Afghanistan, Iran and Pacific Islands. Now if you talk about Japan here, the preparedness, the awareness about different events is so high amongst the community or the society that they are able to minimize the hazard or the risk in all senses. But in India, if similar magnitude earthquake occurs, or in Afghanistan, Philippines, number of toll will go high, that is number of fatalities or people getting killed or people getting injured, and property loss will be much higher. Many of these countries in the region are located along or adjacent to Pacific Ocean seismic zone or the Indian Ocean seismic zone. We will come to this, what do you mean by seismic zone and what is the Pacific seismic zone and Indian Ocean seismic zone. But in short, I can talk about this quickly, is that Indian Ocean seismic zone is the zone along which 2004 earthquake took place, that was of Sumatra, Andaman. Magnitude was 9.2, and it also triggered the devastating tsunami. For example, 50 to 60% of India is vulnerable to seismic activity. So, in one of the slides we are talking about the coastal areas. We are having the coastal regions, or the coastline, which is more than 7,500 kilometers. Out of that, almost like 5,000 is vulnerable. That is what we talk here, that even the land area, including the land area also, almost like 50 to 60%. So, more than half of the Indian plate or the Indian peninsula is or Indian subcontinent, we can say, is vulnerable to seismic activity, and that also of varying intensity, particularly the area in Himalayan region and the Union Territory of Andaman and Nicobar. So, if I quickly draw a very rough sketch here, so this is your Indian northern part, and then it comes down here, and then we have something like that. Okay, very rough sketch I am putting in, and then we have the islands which are sitting here. Okay, so this is an Andaman subduction zone, and this part is your Himalayan collision zone. So, and apart from there, so this is one zone which is very dangerous, another zone is here, third is here, and that is in the Kutch region, and one is which is Narmada zone area, which is in the center. So, most of the area is under the threat of seismic activity. So, example, if you look at, because if you say more than 50 to 60% area is vulnerable to seismic activity, we have experienced the earthquakes in the region which were been considered as unstable continental regions, like the earthquake in Maharashtra state in western India in September 1993 claimed almost 12,000 lives, and in January 2001, that was in Bhuj earthquake, claimed almost 20,000 lives, and more than a lakh due to 2004 Sumatra Andaman earthquake. So, these are very if we look at in 20th century, we had couple of earthquakes, but in 21st century we had the damaging earthquakes like 2001 Bhuj and 2004 Sumatra Andaman, which also accompanied the tsunami. Now, in most of the literature you will find this correlation between the average number of earthquake per year worldwide and a comparison of the amount of energy they expand. Okay. So, the amount of energy release is compared with the energy release here, which is equivalent in kilogram of explosives. Okay. So, 2004, here it has been listed close to the second largest one, but in some literature it says that 1964 was comparatively, or maybe we can say a little bit larger as compared to 2004, but the largest was 9.5. This was the Chilean earthquake of 1960, 9.5. Alaskan has been put somewhere around 7.4 or 9.4 or 9.3, and this was around 9.3. So, this becomes almost close to the second largest one. And then if you look at here, it has not been listed, but 2001 Bhuj earthquake will lie somewhere here. It was 7.8 magnitude. Another important point which we will be talking later, but right now I will just quickly discuss, is that we are basically interested in knowing that how deep the earthquake will be, how far the earthquake will be from a particular site. Suppose we are having some town sitting here, then how far will be my epicenter from that particular region. Another part, what is the site condition. Like here what has been shown is this dotted layers are all sedimentary rocks, and then we have the deeper part are very hard massive rocks, very old ancient rocks. So the ground acceleration in this rocks will not be so effective as compared to which we will experience in the softer material. So how far my earthquake epicenter will be from the site of interest or my particular site where the population is there, and what are the features which one can identify. This we are going to talk in coming lectures about when we are talking about the earthquakes. But two important points which you should remember is that what will be the site condition where you are going to go for the construction or the development, or where you are staying at present. How far is the source located of particular earthquake, that is an epicenter, where is the expected epicenter will be located. Now this all is important because the ground shaking of different magnitude will vary from place to place, and that will be dependent on how far you are sitting away from the source. Second is that depending on the lithology, that is what the ground conditions, if it is softer then the ground acceleration will be different. If it is hard rocks then the ground conditions will be, or ground shaking will be different. Apart from that, how much will be the shaking, that is time of shaking will go on, and that varies depending on the magnitude, that varies depending on the material in which the ground shaking is experienced. That will result into the damage pattern, or that will affect the area accordingly. Also the geologists and the people who are dealing with seismic hazard assessment will also be interested in knowing that how much will be the displacement and the distance, how much will be the rupture length. Depending on that you can fix up the magnitude. Now this all information research groups keep on collecting day by day when they experience the new events, but at the same time they try to get back into the history based on the surface manifestations of the earthquake features, and then talk about that what is the expected magnitude in that particular area. That is what we are talking about, the preparedness capacity building, and that will help us in minimizing the hazard part. This is an example from China, August 3rd, 2014. Earthquake magnitude was 6.1. The damage was again massive. Pattern of damage in Kutch due to 2001 Bhuj earthquake, magnitude 7.8. In the epicentral area where maximum ground shaking was experienced, the land was broken in different multiple fractures. This is what we call lateral spreading. Also, because the most of the area was occupied by the soft deposit, the area also experienced liquefaction. Now about this process we will talk later when we are talking about ground effects, because this liquefaction is the part of the ground effects caused by strong seismic shaking or earthquake related shaking. This is a picture, aerial photograph from Gandhidham area near the coast, and the black dots which you see here are all the silt and fine sand material poured out on the surface, and the whitish part which you see is the salt farming. So similarly, what you see here, the water was been gushed out or poured out along with sediments because of strong ground shaking. We also term this as in sand blows, very much similar to the volcanic cones. The damage was extremely severe. Many villages, towns were razed to ground. Site effect can also damage the buildings, not only just collapse, but it also allows the building to sink down completely. This is an example from 1964 Niigata earthquake of 7.6, where the building got tilted. As you see here, this was because of the massive liquefaction. The soil or the foundation of the material on which this building was standing lost its shear strength because of strong ground shaking. So this is another issue which massively we can face in Indo-Gangetic plain, because of if there is an earthquake which has been triggered along Himalaya, could result into such type of damage related to liquefaction. This is from Christchurch, earthquake in New Zealand. This is one of the best example which usually I admire, is that how the geologists or the seismologists were well prepared, because they understood the phenomena and they predicted that what will happen in future if an earthquake of similar magnitude occurs along a particular fault. So on Earth's surface there are locations which will have earthquake related faulting or the surface ruptures, and this fault lines occurs in most of the areas where the activity is quite prone. So seismically active regions will have fault lines which we cannot avoid. We have to live with it, and if any construction has been done, we try to be away from such fault lines, because this fault lines or the area will get ruptured, or the surface will get ruptured or fractured during the next earthquake. So identification of such fault lines is extremely important. At the same time, need to understand that what will be the expected magnitude on such fault lines and what will be the sense of movement on such fault lines. So the geologists and seismologists, they worked very hard on this, and the project was in this area was of to transport the crude oil through pipelines. Now just on giving a background of this area is that what we were talking about, the seismic plate boundaries. This is a plate boundary between two plates, again Pacific plate, and you are having North American plate. So this is the boundary between that, and this plate is subducting below, that is Pacific plate is subducting below the North American plate. So because of the deformation which is caused by subduction here, a lot of fractures or the fault lines have evolved and have also resulted or caused earthquakes in past. So they were quite sure that since these are been identified as an active fault lines, they have potential to trigger earthquake in near future. So the pipeline was aligned across the Denali Fault. Now this Denali Fault was identified as an active, and also they knew that what is the sense of movement along this fault, that is the Denali fault, and if at all it slips in future, how much is the expected displacement they are going to experience. So what they decided, that earlier the pipeline was been planned to be put underground, but since they knew that this is an active fault where the fault line is crossing and this fault may move in near future, so they decided to put the pipeline on surface over a roller coasters, and the pipe which was used for that transit was quite flexible in sense. Okay, so they used different material, they brought the pipeline on surface, they put the pipeline on the roller coaster with an understanding then an earthquake with magnitude 7.9 or 8 will occur on this, and this happened. The earthquake was triggered with magnitude 7.9 on Denali Fault. The investigation before the earthquake and before putting this pipeline suggested that the fault may move by about 20 feet. If it ruptures, it moved 18 feet, and the pipeline did not face any damage. So this is how we were talking about that if you know and understand the hazard, you can minimize the loss part. So the one of the good example, I'll stop here, and we'll continue in the next lecture and talk more about the earthquakes.